Hi, I'm Saurabh Jalnikar. I'm going to explain you the second problem of probability and stochastic processes homework time. So in this problem, we have to define various processes such as white and stationary, independent increment process, Markov process, normal process, strict and stationary, white noise, etc. Now let us start with white and stationary. A stochastic process is wide and stationary if its mean is a constant and autocorrelation is a function of time difference. So this is how wide and stationary process is defined. Now independent increment process. Now independent increment process means the increments xt1 minus xt2 and xt3 minus xt4 are non-overlapping intervals and are independent. So this is independent increment process. Now a Markov process is defined as if xt is said to be a Markov process if the past has no influence on the future when the present is known. So in this case we know the present values and the past values, they don't have any impact on the future values. So this is known as Markov process. A normal process. So normal process xt is said to be a normal process if the random variables xt1, t2, t3 are all jointly normal for any n and any time t1 to tn. So its density function is defined as f x, x1, x2, xn. Joint density function t1, t2, tn is equal to 1 upon. This is very close to the normal process. The normal density function. Only this is, it has many random variables, so it is 1 upon 2 pi raised to 1 determinant of c raised to minus half x minus eta raised to t c inverse eta x minus eta. Okay. Now a process is strict and stationary if it is strict, so its statistics are not affected by the shift in time. So that is strict and stationary. Now moving forward, we have white noise. So like if you have linear process Wt, if its derivative Vt of, if it takes derivative, we have e, and if it find its mean is equal to 0 and its auto correlation is equal to alpha lambda alpha into delta t1 minus t2. The stochastic process is said to be a white noise if expected value is 0 and its autocovariance is q of t1 delta t1 minus t2. Now mean ergodic process. A stochastic process is said to be mean ergodic if its limit t tends to infinity 1 upon 2 raised to t in the interval of minus t to t x of t dt is equal to e of xt. So this equals to the mean. If this is the condition, then the process is said to be mean ergodic process. And the last process is martingale. The process is said to be martingale if its expected value given x of s is equal to x and that is equal to x1 where this s is less than t. Thank you.